So, welcome back. I'm assuming we have gotten through the first page of applications together. Probably started some of page 2. I'm not totally sure where we'll have ended, so I'm just going to start at the beginning of page 2, and we'll crop this as need be. So, the next application we're going to look at are initial value problems that you looked at in section 4.1 during term 2. We need to solve this differential equation. And you should remember that to solve a differential equation, I'm giving you the derivative, I want to know the original function, we need to integrate. Y of x is going to equal the integral of 3 over 2 minus x dx. To be able to integrate this, we need to do a u substitution. Can you tell me what u is? I'm going to say u is that denominator, 2 minus x. And then what's du going to be? Well, just the derivative of that, negative 1 dx. That 3 wasn't helping anything. So before I start doing any work, I'm going to move that 3 out front and say 3 times the integral of dx over 2 minus x. I want a negative inside. Cancel it out with a negative outside. This is going to become y of x equals negative 3 times the integral of du over u. I think you can probably handle integrating that. Please go integrate, get your general solution, and stop. Y of x is going to equal negative 3 times the natural log of the absolute value of u plus a constant. That's going to give me y of x equals negative 3 times the natural log of the absolute value of 2 minus x plus c. That is my general solution. Now I need to use my initial condition to find the value of c. I'm going to plug in 1 for x, 0 for y, and solve. 0 equals negative 3 times the natural log of the absolute value of 2 minus 1 plus c. You know what? I think you can probably handle this. Tell me what c equals. Well, 0 equals negative 3 times the natural log of 1 plus c. Natural log of 1 is 0. 0 equals 0 plus c. My constant is just 0. Your solution to the differential equation is y of x equals negative 3 times the natural log of the absolute value of 2 minus x, and that is it. No plus c, because c was 0. In number 5, solve that differential equation. We're going to get y equals the integral of x e to the 2x squared dx. I think you could probably go figure out your general solution. So go do that. I hope you realize we have to do a u substitution. U equals 2x squared. Du equals 4x dx. So 4 in, 1/4 out. And we're going to get y equals 1/4 times the integral of e to the u du. That's going to give us y equals 1/4 times e to the u plus a constant. This is y equals 1/4 e to the 2x squared plus a constant c. I think you can probably handle figuring out the c value. Take a moment, plug in 0 for x, negative 3/2 for y, tell me what c equals. I am thinking negative 7/4 for my c. Remember, so that's the answer you should have submitted to Edpuzzle, but remember that's not the solution to the differential equation. The solution to my differential equation, or my initial value problem, is y equals 1/4 e to the 2x squared minus 7/4. That is my solution. One more of these. we are going to solve a second order differential equation. Hopefully this looks vaguely familiar from your section 4.1 work from term 2. We need to integrate this, find our constant, and then we need to integrate this again. F prime of x, actually, hold on, let me just move down to the camera rather than moving the clipboard. Okay, f prime of x is going to equal the integral of the sine of x plus e to the 2x dx. Now, no u substitution. Yes, u substitution, which means I need to split this into two different integrals, do a u substitution on one, and just straight integration on the other. I'm going to integrate sine x dx plus the integral e to the 2x dx over there. You need to use a u substitution here. You don't need to do that over here. Go get your general solution for f prime. So this is what my integrals should become. The integral of the sine of x is negative cosine x. Over here, 1/2 e to the u plus a constant. So I'm going to get f prime of x to equal negative cosine x plus 1/2 e to the 2x plus c. At this point, you need to plug in 0 for x, 1/4 for f, sorry, nope, ignore what I just said. You're going to plug in 0 for x, 1/2 for f prime, and you're going to solve to get your c value. What is your c value? Okay, so 1/2 equals negative cosine 0 plus 1/2 e to the 0 plus a constant. Cosine of 0 is 1, so this is negative 1. E to the 0 is also 1, so 1/2 plus c. 1/2 equals, oh goodness, negative 1/2 plus a constant. I think your c is 1, which tells me that f prime of x is going to equal negative cosine x plus 1/2 e to the 2x plus 1. You then need to integrate this thing again. And you know what? Since both of these pieces won't require a u substitution and this one will, I'm going to kind of rearrange things a little bit. And I'm going to say this is going to equal the integral of negative cosine x plus 1. I can handle both of those with basic antiderivative rules. Plus 1/2 times the integral of e to the 2x dx. Normal, u substitution. See if you can finish off this entire problem and send your final answer, not just for the c value, but your final answer for f of x into Edpuzzle. Okay, so I'm getting my general solution like this. I'm then going to plug in my 1/4 and my 0. I'm going to get 1/4 equals negative sine 0 plus 0 plus 1/4 e to the 0 plus c. That's 1/4 equals 0 plus 0. This part becomes a 4. Oh, this is going to be nice. C is just going to equal 0. So your final solution to this differential equation is negative sine x plus 1/4 e to the 2x. Whew. One thing I definitely wanted you to be able to see, though, from this problem was how we split it into different integrals, some of which were just straight integrals, while others required use substitutions. I'm going to make the video pause if there's anything here that you need to continue copying down. Okay, so the next application we're going to take a look at, area under a curve problems. Number 7, I want to find the area under that function from 1 to 4. I hope you remember that area under a curve is just a definite integral. I'm going to integrate x squared plus 4 over x dx from 1 to 4. And this answer will be the area under that curve. Now, you should look at this and notice, oh, degree of the numerator is greater than or equal to the degree of the denominator, which means division. I could use long division, but I think the better way to go here is just to separate the fraction and divide by that way. If the denominator was like x minus 2 or something, there'd be no way around real division. But I think here I'm just going to say x squared over x plus 4 over x dx, which just gives me the integral from 1 to 4 of x plus 4 over x. I don't think either of these will require a u substitution. I think this is just power rule over here, and this looks like our natural log rule. I'd like to see if you can go find your antiderivative, plug in 4 minus plug in 1. Give me a final answer to problem number 7. What is that shaded area? Okay, so 4 squared over 2 plus 4 ln 4. Then I'm going to plug in my 1. 1 squared over 2 plus 4 ln 1. 4 squared, that's 16 divided by 2, that's 8. Plus 4 ln 4. Minus a half, minus, I'm not even going to bother with this because I know the natural log of 1 is just 0. So I think I just have to do 16 halves minus 1. I'm thinking 15 halves plus 4 ln 4. And by the way, I guess I should have mentioned this earlier, but we're always giving exact, unless I tell you otherwise, we're always giving exact answers for these problems. So, the next thing we're going to take a look at is number 8. Take a moment and set up your definite integral that will find the area. I hope you did a problem like this. Integral from 0 to 2 of e to the negative 2x plus 2 dx. Now, u substitution, no u substitution, which means we need to make two separate definite integrals. We're going to go from 0 to 2, e to the negative 2x dx, and 0 to 2, just the constant 2, dx. I think you can probably go from there. Do your u substitution, change your limits, and all that good stuff. No u substitution here. You can either use power rule or just use geometry on that thing. Let's see what you can do with this. Send your final answer into Edpuzzle, please. And make sure it's an exact answer, no decimals. Negative 2 in, negative 1/2 out. Negative 1/2 times the integral of e to the u du. The limits, 0 becomes negative 2 times 0, or 0. 2 becomes negative 2 times 2, or negative 4. I'm just going to leave my limits as is and let fundamental theorem of calculus take care of the signs. Over here, I think I'll just use fundamental theorem of calculus, but again, you could use geometry, just saying it's a horizontal line at 2 and deal with all that stuff. You're going to get negative a half times e to the u from 0 up to negative 4, plus this one, this is 2x from 0 up to 2. I'm going to plug in negative 4, e to the negative 4 minus e to the 0. Over here, I'm going to plug in 2 minus, I'm going to plug in 0. This is negative 1/2 times 1 over e to the 4th minus 1 plus 4 minus 0. Bring it up a little, negative 1 over 2e to the 4th plus 1/2 plus 4. This looks like negative 1 over 2, oops, I'm off the screen. Negative 1 over 2e to the 4th plus 9/2. And that is the exact area under your curve. Make the video pause so you can get any of that in your notes that you need to. Next page, page 4. I'm going to warn you, there's a reason that there's one problem on this page. This gets a little bit messy. We want to find the coordinates of any relative extrema and points of inflection of y equals x over the natural log of x. Relative extrema, relative maxes, and relative mins come from us looking at the first derivative. I want to find y prime, I want to figure out where y prime is changing signs, and all that stuff. Well, we first need y prime. We need the derivative. We need to use quotient rule on that. Please take a moment, calculate your derivative. Y prime is going to equal. Okay, so low, natural log of x, d high is times 1, minus high, x, d low, 1 over x. Draw the line, square below. This is all over natural log of x in parentheses squared. I don't want to leave it like that. I want to clean this up. I want to say the natural log of x minus, this thing is just 1 minus 1 over the natural log of x in parentheses squared. That is my first derivative. I'll wait till this focuses. Oh my gosh, come on. What happened? Why are you not focusing? Nope, that's not going to help anything. We're going to move that. Are we back? We're not. Okay. Is this any better? Oh, hold on. That's a problem. Oh, now I'm back. Okay, just ignore me. Sorry for that. Now I need to make my number line. I need to find my critical values. I need to figure out what makes the derivative equal 0 and what makes the derivative undefined. I hope this is sounding vaguely familiar from term 1. I need to get my critical values. Where are they coming from? They're coming from saying the natural log of x minus 1 equals 0, and they're coming from saying the natural log of x equals 0. Now, how am I going to find these? Well, I need to solve my equation. Plus 1, natural log of x equals 1. You can undo a natural log by doing e raised to both sides because e and the natural log are inverses, and you're going to get x equals e. I'm going to do the same thing over here. When you solve this equation over here, what do you get for your x? So e to the natural log of x equals e to the 0. That tells me x equals e to the 0. That tells me x equals 1. I'm going to make a number line. I'm going to label it y prime. I'm going to include 1. I'm also going to include e on my number line. Now, there's something else we need to talk about. This original function had a natural log in it. What you plug into the natural log cannot be 0 or negative, which means I'm actually going to put a boundary over here at x equals 0. You are not allowed to plug in 0. You're not allowed to plug in anything less than 0, because it would make the original problem undefined. I need to test my regions, and before we do this, it might be really helpful for you to get out that little strip on an orange piece of paper that was in your packet of stuff with the graphs of e to the x and the natural log of x. I'll pause, go grab that little strip. I need to plug in some values here. How about I plug in something like a half over there? I'm plugging into y prime. When x equals 1/2, y prime is going to equal the natural log of a half minus 1 over the natural log of a half squared. All I care about is, will this answer be positive or negative? Well, the denominator here is always going to be positive because we're squaring something, so it doesn't really matter what's going on there. Denominator's positive. Natural log of a half. Look at your graph of the natural log of x. Is the natural log of a half positive or negative? I hope you were looking at that graph of the natural log of x. That looks something like this. I think natural log of a half, that's some negative value. Take some negative value, subtract 1, it's even more negative. What is a negative over a positive? It is a negative. Your first region is negative. I'm going to go through similar logic now in this region and that region. When you plug in 2, you're going to get y prime equals the natural log of 2 minus 1 over the natural log of 2 squared. Again, the denominator is always positive. Natural log of 2 is some positive number. A positive minus 1, not really sure. But I know that the natural log of e is 1. 1 minus 1 is 0. So the natural log of 2 has got to be something less than 1. Something less than 1 minus 1 will give you something negative. This region over here will be negative. Finally, let's plug in something greater than e, maybe something like 3, because we know e is 2.71828, all that good stuff. Natural log of 3 minus 1 over the natural log of 3 squared. Again, denominator is positive. Natural log of 3, well, here's e, and the natural log of e is 1. Natural log of 3 is something greater than 1. Subtract 1 from it, you're going to get a positive number. A positive over a positive will give me a positive, which means my graph of the original function is decreasing, decreasing, and increasing. I have something at x equals e. Is it a relative max or a relative min? I hope you can see from those little symbols, I've got a relative min at x equals e. There is a min at e, comma, I'll figure this out in a moment. Didn't ask me to justify the answer, so I guess I won't bother with that here, but why? Because y prime is changing from negative to positive there. Now, I need to find the y-coordinate. How would you figure out the y-coordinate of the minimum? We need to go back to the original function. We need to go and plug e into our original y of x problem. We're going to get e over the natural log of e. Natural log of e is 1, e over 1. Kind of weird, but whatever. My minimum occurs at e, comma e. I hate to say this, but if you found this rough, just wait till the next half of this problem. Also, they'll promise, after number 9, this curve sketching stuff will get a lot cleaner. Make sure this is all in your notes. Next, I need to find my second derivative, which means I need to take my first derivative and do the derivative of that. Y prime equals the natural log of x minus 1 over the natural log of x squared. How about you see if you can go create the formula for y double prime? I'm going to use quotient rule. Low, natural log of x squared, d high times 1 over x, minus high, natural log of x minus 1, d low, I got to use the chain rule on d low. I'm going to get 2 ln x, and by chain rule, times 1 over x. Draw the line square below. This is all over the natural log of x. That thing in parentheses, squared, squared, so to the fourth. Let's see. I'm going to factor out a GCF. I might as well start by doing that. I see a natural log x and a 1 over x in both terms. So I'm going to get natural log x times 1 over x out front. I'm going to be left with a natural log of x from here minus 2 times the natural log of x minus 1 from the second piece. This is all over the natural log of x to the fourth. I can cancel a natural log. I can move this x to the denominator and do some distributing up top to get natural log x minus 2 ln x plus 2 over x times the natural log of x cubed. And I think this is going to give me 2 minus the natural log of x over x ln x cubed. Okay. We now need to find the possible points of inflection. We're going to set the numerator equal to 0. I'm going to say 2 minus the natural log of x equals 0. And I'm going to set the denominator equal to 0. X equals 0, and natural log of x equals 0. Go solve those. Actually, I guess this one's already solved for you. Go solve these two. Get your possible points of inflection. Natural log of x equals 2. E to both sides. I think a possible point of inflection is at e squared. For here, e raised to both sides, x equals 1. I'm getting 0, 1, and e squared. So, tick marks at 1 and e squared. I'm going to label my number line y double prime. I'm going to go plug, let's see, I'm going to plug in a half to my second derivative. That's going to give me 2 minus the natural log of a half over a half times the natural log of a half cubed. Okay, for starters, is the natural log of a half positive or negative? I think that should be negative. You are looking at the graph over here. Natural log of a half, some sort of negative number. So 2 minus a negative, that's going to make that top positive. As for the bottom, this is clearly positive. Natural log of a half is negative. Cube a negative number, you get a negative number. Positive over a negative is going to make your first region negative. Now, as for a good number between 1 and e squared, I actually think a really nice number to plug in would be e. And if I do that, I get y double prime is 2 minus the natural log of e over e times the natural log of e cubed. Please tell me if that is positive or if that is negative. Natural log of e is 1. 2 minus 1 is 1. It's really just positive. That's all I care about. In the bottom, natural log of e is 1. So I get e times 1 to the third. That's positive times a positive. That's positive. This region is positive. What am I going to plug in greater than e squared? I know it might sound weird, but I think it's actually going to be easier to plug in something like e cubed than like 10 or 20 or something like that. And if we plug in e cubed, we're going to get y double prime equals 2 minus the natural log of e cubed over e cubed. Natural log e cubed cubed. The reason this is nice to plug in is the natural log of e cubed, those pieces cancel and you're just going to get a 3 over here. Your numerator is just 2 minus 3, or negative 1. On the bottom, e cubed is clearly positive. Natural log of e to the third, again, that's just a 3. Cubed is still positive. Negative 1 over a positive number, you're getting a negative number there. Concave down, concave up, concave down. Looks like I have points of inflection at 1, comma something, and e squared, comma something. Where are the y-coordinates coming from? Again, you're going to go back and plug into the original function. Tell me the y-coordinate when x equals 1. Okay, I'm going back into the original. 1 over the natural log of 1. 1, oh, wait a minute. That's a problem. Natural log of 1, that is 0. 1 over 0, that's not okay. That actually means I've got an asymptote happening at x equals 1. Can't possibly have a point of inflection there. Concavity can still change, but it doesn't count as a point of inflection. So that's nothing, because this is undefined. Plug in e squared. Tell me the y-coordinate when you plug in e squared. I'm thinking that's just 1/2. No, it's not. I'm not plugging into the right thing. Ignore what I just did. I'm going to plug into the original. E squared over the natural log of e squared. E squared is e squared. Natural log of e squared is 2. You're going to get e squared over 2. There is only one point of inflection. It is there. Wow, this problem was a force. I'm going to make it pause so you can copy. We're going to do one last one. I promise it's going to be nicer than this. One last problem. Notice I only gave you a half a page of room to work here. That's a good thing. Same question, relative extrema and points of inflection of that function. Well, relative extrema, you need the first derivative. To me, that looks like product rule with a little bit of chain rule inside there. Please go calculate your f prime of x, and when you're done, I'd like to see if you can factor it as far as you can go. First, x times derivative of the second is e to the negative x times negative 1, plus second, e to the negative x times derivative of the first is times 1. I'm going to clean it up. F prime of x equals negative x e to the negative x plus e to the negative x. And I'm out of focus. Okay, I'm going to take out an e to the negative x. And I'm left with this. I need my critical values, so I'm going to set these two parts equal to 0. I'm going to say e to the negative x equals 0, and I'm going to say negative x plus 1 equals 0. I'm going to solve this by getting rid of the e by taking the natural log of both sides. Natural log of e to the negative x equals the natural log of 0, so negative x equals... Oh, wait a minute. Natural log of 0. I'm pretty sure natural log is 0. Yeah, that is undefined. And if you look at the graph, that's where we have that vertical asymptote on the natural log of x. All this means is we are not getting any critical values from the e to the negative x part. So there's really only one critical value. Over here, negative x equals negative 1, x equals 1. That's our critical value. I'm going to make a number line. Now, there are no domain issues with this problem. You know that the graph of e to the x looks like that. You can plug in any x value. Goes left forever, goes right forever. There are no issues with this. So really, I only have one critical value, no bounds. I'm going to plug in, I don't know, maybe I'll plug in 0. When you plug x equals 0 into your first derivative, you're going to get e to the 0 times 0 plus 1. Well, e to the 0 is 1. This thing over here is 1. You're positive there. If you plug in x equals 2, you get e to the negative 2 times negative 2 plus 1. You know what? E raised to anything, no matter if it's a positive number or a negative exponent, that thing is always positive. So actually, this doesn't affect my signs at all. I can really just focus on that piece. You're plugging in negative 2 plus 1. You're getting negative number there times this positive thing. Your final answer is going to be negative. There's a relative. Help me out here. Relative what at x equals 1? I hope you said relative max at x equals 1. 1 comma, go tell me the y-coordinates. 1 comma what? I'm going into the original here. 1 e to the negative 1. I think that's 1 over e. That's where we have a relative maximum. Points of inflection. We need our second derivative. I think we should get it from this version of the first derivative. Do I want to do that? Oh, you know what? Ignore that. Let's get it from this version of the first derivative. I think you need product rule and chain rule over here. Just chain rule over here. See if you can get your second derivative and factor it fully. So let's see. How about I leave the negative out front, and I'm going to say x times e to the negative x. So first, x times the derivative of the second, e to the negative x times negative 1, plus second, e to the negative x times derivative of the first is times 1. Or you could have said it was negative x times this, and whatever. It'll work out in the end. Second part, I'm using chain rule on, e to the negative x times negative 1. This gives me negative, no it doesn't, it gives me positive x e to the negative x minus e to the negative x, because I'm distributing that negative, minus another e to the negative x, which I think looks like x e to the negative x minus 2 e to the negative x. I'm going to do the same trick as before, and I'm going to factor out my GCF, which is e to the negative x. We're left with x minus 2. Same issue we had before. You're not going to get any critical values from e to the negative x because that's always positive. You only, sorry, I shouldn't have said critical value. I should have said possible point of inflection. There's a possible point of inflection at x equals 2. Test your regions. What sign are you going to have before x equals 2? Always positive. 1 minus 2, that's a negative number. You're going to get something negative there. Plug in something after 2, again. No, you tell me right now. Plug in something after 2, what sign are you going to get? Again, always positive. Plug in something after 2, this will be positive. Down, up, there's a point of inflection at 2 comma, I don't know. What's the y-coordinate? Y-coordinate over here should be 2e to the negative 2. That is 2 over e squared. So it was a little messy, but not as bad as 9. And I feel like after this, they're going to get a little bit nicer. That is all that I have for today, and we will finish up the curve sketching stuff tomorrow in class.